Hi, I'm Lyle Rodrigues, and this project was developed by Chitra B, Pranjali M, and myself. So our project is a solution to the glare caused by headlights of an opposing vehicle, which tends to blind you if you're driving. So here the headlights are replaced by projectors that cast light everywhere except on the driver's face. So the headlights are still effective, but at the same time do not impair the vision of the person who's driving the opposite car. So this system benefits the opposing driver and not the driver of the car where it's installed. So to be properly effective, both cars have to be armed with this. So what you need is a camera of at least 116 to 120 pixels resolution, a projector if you're simulating it, and 2 if you're implementing it, an image processor or a PC with MATLAB, and the last thing, you need are 2 bright lights to act as headlights. To explain the block diagram, the output of the camera is fed to the processor, which generates the image for the projector to display. In the processor, first the brightest points of the image are detected. This is done by reducing the overall brightness of the image till only the very bright pixels stand out. Then these points are tracked in pairs, and an approximate position of the driver's eyes or face is calculated. Now a rectangle is plotted around the driver's face, wherein no light is thrown. This is how the system is rigged. So the program searches the image for the brightest points. These are tracked and labeled. After tracking all these points, the points are compared and checked for pairs based on a set of rules, which I'll show you in the program. Using the position of these pairs, the position of the mask for the driver's face is calculated and then generated. So the image displayed by the projector is bright everywhere except for the mask. So the driver's face is not affected by the headlights. Alright, so the program mainly consists of a few initializers and a loop. The loop runs until a certain number of frames that you set are captured. So when the loop starts, a frame or an image is captured from the primary input device. From here, the image exposure is reduced until only the really bright portions stand out. These are grouped and labeled, and these form blobs. From here, 2 nested for loops run, where these blobs are compared with each other and 3 conditions are checked. The first is that the angle between these 2 blobs should be less than 15 degrees compared to the horizontal. Then the area between them should be maximum of 2500 pixels apart from each other, and the height of these should be less than 300 pixels from each other. If these 3 conditions are satisfied, it considers these a pair of headlights from an opposing vehicle, and it starts plotting the mask. The mask is calculated by these commands. On the figure, the shadow is plotted based on the distance between the lights and the size of the lights. Here's the output.